So, hello everyone. I guess we could start now. So, hello everyone. Thank you all for joining us this evening. I'm Ruta Bitin. I'm part of the Women Tech Makers Ethiopia core team. Um, and we are thrilled to welcome you back for week two from our from design to market mentorship session. Over the past few months, WTM Ethiopia has had the honor of connecting incredible tech professionals from all around the world. And this mentorship session is one of our ways to help you grow, connect, and discover your full potential. So last week, we kicked off the series with a fantastic and incredible session on product management led by Omolara Oshiemi. She walked us through MVPs, agile practices in Glaxo. So I'm incredibly excited and honored to welcome Lidiya Tilahun, a software development engineer at AWS or Amazon Web Service. And without further ado, please welcome Lidiya Tilahun. So Lidiya, the floor is yours. You can unmute yourself and introduce yourself.
All right. Should I also start sharing my screen?
You could.
Okay, then I will start.
Okay.
Mhm. And then I can introduce myself while I'm sharing. Hello, everyone. I hope you can see my screen. Can you see my screen?
It's visible, yeah.
Perfect. Okay. Welcome to another session of From Design to Market. I am your speaker, Lidia. I am a software development engineer at AWS. As Ruth already mentioned, I am based in Berlin, Germany. To quickly introduce my journey, I've been in the tech industry for 9 years. I did my bachelor's in computer science in Germany, and then I had my first job at IBM. At IBM, I worked for 5 years as a software developer, as well as partly as a DevOps engineer, just because I had the interest in it. Where do our the software we develop go, kind of. So IBM was also the beginning of my career. After that, I joined AWS. I've been at AWS for, I think, 4 years. I think 4 years now. So at AWS, I have more of a customer-facing role. So I've worked on more than a couple of customer-facing projects, both as an individual contributor and as a tech lead. Today, I'm going to walk you through system design. Just a few logistical stuff that I have to say. I'm not speaking on behalf of AWS today. I will be discussing only system design, and I won't be discussing AWS product here. And I'm excited to learn or to kind of share system design process with you. And if you have questions, I don't know how this workshop normally go, but feel free to stop me, or if you also want to save it until the end, I will be happy to answer your question. So let's get started. So what I have for you today is we start with the fundamentals, what is system design, and then we talk about why do we learn it, why don't we just start coding right away. And then I also want to share some core principles that will help guide you to design resilient and scalable systems. Then we'll go through a design process, so the steps of designing a system. Then I also want to do a case study with you because we will be talking a lot, and I want to actually give you an example of how an actual designing process would go. I also will share with you some useful tools that I find helpful when I'm designing a system. Then we'll open it up for a Q&A. Okay, so what is system design? I'm sure most of you have heard of it. Some of you also have designed a lot of systems. I would like to use a house analogy because I always like to tie it to a real world. Makes it easy to grasp as well. So before construction begin, when you want to build a house, architect assess the land, they try to understand the client needs and design some sort of plan or blueprint that outlines the house structure and layout, like the plan of where the bedroom is going to be, where the bathroom is going to be. Is it a villa? Is it a bungalow? Is it a high tower building? Because answering these questions early on would have the approach of your construction would be different based on the answers. So, in a similar way, system design is also pre-planning that helps you avoid any problem at the development phase. It includes researching, it includes requirement gathering, it provides the backbone to handle exceptional scenario and at the software development phase. So it's basically a blueprint of the software that you're going to build. And it's very vital and key for building complex and reliable applications. So why? Kind of covered why, but there are different consequences if you don't get the system design part right. Of course, there is no such thing as a perfect software, right? No matter how much of your system was designed, how thoughtful you were, there will always be some unforeseen circumstances, but you will also be amazed by how many of them you could prevent by pre-planning and by designing and by asking the right questions. So some of the consequences, the obvious one is customer dissatisfaction, right? If you don't have a good system, if your website is very slow, customers are not going to be visiting your site, so you will lose customer. The other one is financial consequences. It's also obvious. If you lose customer, obviously that means you lose revenue. The other one is reputation. So in some cases, to uh, cite Meta, for example, Meta sold a lot of users' soft data without users knowing, and that had financial consequences, also reputational consequences. Imagine if your customer trusts you. Let's say your system was saving some credit card information and that got leaked. The customer trust, one, you will lose customer trust, and also your reputation to actually go back to business again will be affected, or your reputation will be tarnished. In the worst cases, it could also end your company and your service, and in a very dire situation, it also affects human life. And when I say this, I'm not exaggerating. I want to give you an example. So the UK Post Office has been using a software called Horizon. It basically handles the day-to-day transaction of sending and delivering packages. And this software had bugs that caused it to report accounts under the employees were missing money. So it fabricated transaction, it duplicated transaction, and it made it look like employees were stealing thousands of and thousands of pounds. And as a result, 736 post office operator were convicted. So people lost jobs, family. One woman was sent to prison while pregnant. And in a very, very unfortunate case, a man also committed suicide because the system said you owe 100,000 pound to UK Post Office. So it's very important. When I say designing a good system is very crucial, this is what I mean because it has a uh, real life consequences. So, how can we avoid this from happening? I have some core principle that will help you avoid this issue and build quality software, and we'll go through each of them. Let's start with scalability. So scalability, as the name suggests, is the ability of the system to handle an increasing amount of workload or its potential to accommodate growth, right? So how are you going to meet the need of incoming traffic? So that means you need to understand your traffic. How is it going to grow? Is it exponential? Is it a slower rate? What you don't want to do is you don't want to optimize early. So let's say you have a very awesome scalable system, but that was an overhead that you didn't need because you don't have that much customer. On the other hand, you also don't want to be not prepared for a huge traffic that is coming. So you really need to understand the traffic before you start building. So in terms of scalability, there are two types of scalability options. So you can do vertical scaling. So with vertical scaling, basically what you're doing is adding more power, CPU, RAM onto an existing server. So you're not adding an additional server, but you're just buffing up the server that you have. To give you a real world example, let's say you have a cafe. And because you're expecting a lot of customers, what you do is maybe you employ more cashier, you increase the size of the door, you maybe rent out the second floor so you can accommodate more people. So this obviously has a limit to how much it could accommodate. So the second one, which is a bit more scaled out and flexible, is horizontal. Yeah, is there a question? Okay, okay, then I will continue. If there is questions, please stop me, unmute, and then you can ask me. So the second one is horizontal scaling. Horizontal scaling means adding more servers. So to go back to the cafe example, if you have a cafe now, you have few branches. You have a branch in Bole, you have a branch in, I don't know, Piazza. These are some places in Addis. So you have more branch to be able to accommodate. Of course, this would cost you more, but it would handle more traffic. So the other principle is availability and reliability. So when we mean a system is available, that means it has continuous operation. So if you have a website, um, I won't be able to read comments in case it's for me. Just unmute. So for availability, it means ensuring operational. So to go back to the cafe example, if you are open from Monday to Sunday, you're very available. So a system that's always operational and available for the user, it has high availability. Maybe you have seen tags like availability 99.99%. And to make sure your system is available, there are a few things that you can do. One is load balancing. So load balancer will help you split the incoming traffic across multiple server, so to prevent overloading any one of them. Because if you overload your server, then your server might go down. Another thing you can do is have a CDN or a content delivery network. It caches the user content very close to where the user is, and it will, in case your server is down, you can also reply with the cache, and then it enables faster delivery of content to the user, such as like web pages, movies, and photos, and so on. Another mechanism that you can implement is redundancy. So have a backup for your critical components. So if one fails, another one can take over without affecting the system. So have a replication of data across different servers, do backups, and if you're doing a regular updates and maintenance, schedule those off peak hour. So the next one is reliability. Reliable system is less likely to experience failure. Um, and basically, reliability is preventing failure, right? It's one thing that your system is available. So if we go back to the coffee example, your coffee is open from Monday to Sunday, but if the cashiers are not doing their job correctly, then it's not reliable. So in the same way, if your system is not behaving as it should and is not giving accurate information, then it's not reliable. Some mechanism that you could implement is testing. So implement a comprehensive testing strategies, include stress tests like chaos testing, which you would inject different failures into your system and see how resilient your system is. Integration tests, unit tests. You can design these ahead of time as well. Error handling, develop a robust error handling. So when error, obviously, you know for sure error is going to happen at some point. What you don't want to do is an error crashing your whole system. So fail gracefully, and then monitor log alarms, like continuously observe your system, know what's going on. This will help you prevent any issues before happening, because you can see some of the servers are returning 500 for a continuous time. So maybe someone could take a look at it. So these are some of the things that will help you increase the reliability. The other important metrics is performance. When we talk about performance, it's how efficiently a system operates under a specific load. So it's typically measured using metrics such as latency. So you want a low latency system. Latency is the time it takes to process a request. A throughput is the number of requests handled per minute. That's another metric you could use to measure the performance of a system. And then there is resource utilization. So how is my system using CPU, using memory, and so on. There are different things that you could do to boost performance. Of course, caching, yeah, that will also boost performance. Um, Load balancer, we already discussed load balancer, but it will also help you boost performance by distributing load across different servers. And then also optimizing your code and database, like having or using efficient queries and database indexes will help you with performance. So the fourth principle is also maintainability. Maintainability is how easy it is for you to maintain, update, or upgrade a software system. So always design with the mind that your system is going to change. Of course, you can design a system to be as accurate, but one thing we know is features gets added in the future because even requirements evolve over time. So if it's hard to maintain your system, then it's going to be very hard to progress or even keep your business. There are some things you can do in terms of maintainability, right? Loose coupling and high cohesion. So you should always try to separate or try to lower the dependency or the coupling of modules between each other. And then also group those modules that are focused in a single purpose together. So that's high cohesion. Separation of concern focuses in a similar way, focuses on the overall architecture of the system, basically ensuring different aspects of functionality are handled by separate modules or layers. And there are, of course, much more mechanisms that you can use to implement maintainability, but I'm only mentioning some of them here. And document. Of course, if the code underneath or if your system underneath is not good, documenting is not really going to save that system, right? But documenting helps, or it's like a cherry on top. You have a good system, now you also have a good document to help others update or maintain that system. Security. So, security very important because the consequences are also very dire if your system is not secure. And security needs to be job zero. It's not something that you put or bolt later on. So you have to bake it in your system. And there are very different security measures that you could do. I won't be able to get in all of them, but I copied this cheat sheet from Go, and I recommend you go and check it out yourself. When we share the PowerPoint, you will also get the link. Uh, just to touch upon some key aspects, authentication. So that is, who are you? You make sure your APIs are protected or authenticated. Of course, there are some cases that you have public API that do not need authentication, but in most cases you need authentication. So make sure you have that in place. Authorization is, what can you do? So have a clear set of the user role, right? So a user could have a sysadmin role or a mere or user role. And depending on the role, make sure they have the right permission. Always implement the least privilege access. Don't give permission unless there is a reason to. It's better to start with a very small permission set and then add. Encryption. Make sure your data at rest and data in transit are encrypted. So use TLS or SSL to encrypt data during transmission. So you also use HTTPS instead of HTTP if you have a web page. Your database needs to be encrypted. Most databases already support that. And this is also a very important aspect. Others is inputs validation. Trust no one. If you are processing an input from the user, make sure that you have input validation. And there are certain things like audit and compliance. So it's a very wide topic, security. Um, but one mechanism that helps you build a secure system is threat modeling. So once you have a high level design, you can do an exercise of trend modeling. So trend modeling means you would identify the different actors that you have. So there's user, malicious user, there are developers, and so on. And then there are data, there's the data flow from A to B, and so on. You identify these components and basically mitigate different potential security issues that they might have. So trade-off. Like I said earlier, there's no such thing as a perfect system. So you always would need to trade off. Like one aspect might be more valuable for you due to some business reasons. One thing that would help you is also one-way versus two-way door. This is something that we use in Amazon as well. So one-way decisions are if you make, let's say you made a decision for a paint of the house, and it's very hard to change that paint, then it's a one-way decision. One-way decisions are decisions that are really hard to go back to. Two-way doors are once you make the decision, it's easier to come back and change it later on. So identify which decisions are one-way, which decisions are two-way door, and then if it is a one-way door, make sure that you have enough thought and research before you decide. In the diagram here, I have linked the CAP theorem. So when you're choosing a distributed system like a storage, the CAP theorem says it could only guarantee two of them, not three. So the partition tolerance means your system can handle some network, like if one of the node where your system is running is inaccessible due to a network outage, which is something that always happen, right? It could happen. This is a very likely scenario. So this partition tolerance means it would be fine if that happened. You still could continue with the other available node, with the other available nodes. Sorry. Consistency is you always whatever you always get the whatever you write would be what you get. So basically, if you write, let me give an example that might be better. So let's say you have a bank application, and that bank application is running in two data centers. Let's say one is in Kenya, one is in Ethiopia. And then let's say the one in Ethiopia is down, and there is a user, just for this example case, could be at two places at once. And what this person is trying to do is trying to withdraw money from Kenya and then checking their account in Ethiopia. Mind you, the Ethiopian data center is down. So if you want a consistent system, you cannot let this user withdraw the money, because if you withdraw the money, then the Kenya data center will have the right balance, while the Ethiopian data center, because it's down, won't have the right balance. So it's not consistent. The data is not consistent. The other one is if you want an available system, and you could allow this person to withdraw this $100 or £100, whatever, but that means then it's not consistent, because until the Ethiopian data center is up and running, there will be a discrepancy between what is stored. So this is one a cap theorem that kind of tells you which ones are important to you. So this is like one trade-off. There are different kind of trade-offs that you have to do, right? Scalability versus performance. Maybe you want to scale, but the higher you scale, that would hurt your performance. Which one is important to you? SQL versus no SQL. Do you want a fixed schema? Do you want a relational database? Or do you don't care and you want a flexible, very highly scalable database? Even monolith versus microservice. These are still trade-offs that you have to do when you're designing a system. A monolith might make sense because you have a very small system, and breaking it down would just increase an overhead. For example, Netflix started as a monolith, but of course that didn't work out and they had to change the microservice. But depending on your use case, these trade-offs and asking the right question and going back to the requirement is one important step. So now let's do the design process. Let's look at the steps. The first step is, of course, understanding the requirement, the scope, and this is the most important step, in my opinion, because no matter how much effort you put in the high level design, low level design, and the product, it doesn't matter if you don't have the right requirements. So make sure you have gathered and spend the right amount of time at the gathering requirement phase. Do workshops with your client or with your do market analysis and so on. And then, of course, there is a high level design, which is like a higher overview or an outline of your system. We'll go through each of them one by one, and then there's the low-level design and then the prototype. Let's go with the first step. So understanding requirement and scope, like I said, is a vital step. There are two types of requirements, so the functional and non-functional requirement. The functional requirement is what does the system do? So it's more like business or product oriented. It's statements like, as a user, I should be able to do dash, right? For example, as a user, I should be able to send messages. As a user, I should be able to make a video call. This might be like a functional requirement of Messenger. Non-functional requirements are technical. It's like the characteristic of the system. So how the system scales, how the system is performance-wise. So I want to be able to handle 1,000,000 TPS. I want scalability. I want 99.9% availability because of XYZ. So these are non-functional requirements. So when we go to the high-level design, I will go back to the house analogy. Here you can see a blueprint of a house. Basically illustrate the general layout of the house, right? You don't have so much detail at this point. You don't know what type of material you're using for the kitchen. You don't know what type of material the floor or the roof is. But what you can see is where these big components should be, right? So at this point, you know where the bathroom is, you know where the living room is. For example, I can say, oh, the terrace doesn't make sense next to the kitchen. Put it between the living room and the bedroom, right? This already starts the conversation. So similar to the blueprint of the house that we saw, high level design is an abstract overview of the system's architecture. It's very high level, so you don't need to know everything at this point. But what you need to know are the big components. You need to say, okay, I need this system, I need this service. You can break it down and you can already have an idea of the communication between these components. And then the low level design, this is a house low level design example that I found. So I'm not an architect, but it seems low level enough. So here you could already zoom in into one room and it kind of shows some information about the floor, about the roof, and so on, right? It's more detailed than the image that we just saw before. So in a similar way, low-level design and system design basically zooms in into the number of components that you have sketched out in the beginning, and then now it goes or dive deeps into the details, right? So APIs, the database schemas, classes, and so on, because now you need to have those informations getting very technical. To to kind of compare these two in high level design, it's very overall structure. You have major components. In the low level design, you zoom in into each of the components and then get details, like specific details. And the audience are also different because in the high level design, it's architect, project managers, stakeholders, of course, developers are also involved in some cases. But then in a low level design, that's where builders, engineers, developers are involved. And the purpose of the high level design is basically to map up or like to have the roadmap for the building phase, while low-level design actually guides the actual building. So as a developer, if I have a ticket to implement a feature, I should be able to look at the low-level design to get the details I need. Okay, so now we're gonna go to the case study. I hope I'm good in time. The case study that I want to do with you today is a ride application. So Uber or Lyft, it's called Ride in Ethiopia, or Faras. Um, so the goal is basically to apply some of the principles and process that we just talked about, and then go through an example. So it doesn't become just theory, but you have some practical example. Okay. If it's okay with you, it would be nice if I get some participants. So I've said functional requirements is as a user, I should be able to do X, Y, Z, right? It's more of the business. So here I have some hints like user experience, driver matching, payment, user roles, and so on. Can you give me few requirements that you think if a ride or if you're using Uber, what are some of the functional requirements? Yeah, go ahead.
Well, I should be able to like state my current location and where I'd want to go.
Yeah, that is correct. Any more?
I should be anyone. I should be able to see so how much it would cost
Yeah,
for one ride.
yeah, fair calculation, right? As a user, you expect fair calculation. I see Aida's hands up.
Yeah, so I think I should be able to track the driver's location.
Yep, that's true. Another very core thing that I should be able to do and write. What do you think?
Uh, order driver.
Yeah, exactly. I should also be able to request a ride. So these are some of the functional requirements, and thank you everyone for participating. Um, I have a few things that I already mapped up here, and you already mentioned most of them. Riders are able to request a ride on their phone. They should be able to see nearby drivers. Also, as a rider, after you request it, you should be able to cancel your order. Drivers can accept or decline a ride, and so on, right? These are functional requirements that helps you for the high-level design. Now let's go to the non-functional requirements. So when you think of ride or Uber, we know it has a lot of users that potentially could be requesting ride. If we, let's say, use New York because it's just huge and most people request Uber. Um, what do you think are some of the scalability requirement availability or some of the non-functional requirements? Like you can say, I expect 100 user, but that would be too small, right? Anyone?
I think it should be able to handle around, let's say, 10,000 transactions per day.
Per day or per second?
Okay, per second, let's say 1,000 transactions, so 1,000 ride hailing per
Okay.
second.
But you're right, that is a non-functional metric. But since it's New York, I would really increase it very, very high because I don't know how many people millions of people live, and most people don't drive, but they call a cab or an Uber. So I would increase it. But you're right, this is a non-functional requirement. Any other, Meron?
Um, the app should display nearby vehicles and offer ride options within a certain time frame. Maybe.
So this one is a functional, right? Because you're not necessarily talking about how the system should behave. You're talking about a business. Like us, if one exercise you can do is if the statement is like, as a user, I should be able to see different driving options and so on. These are business. So these are functional requirements. For a non-functional, it should be like
Okay.
the system should have, like Ruth said, X, Y, GPS, or the system should scale to 10 times and so on. Does that make sense?
Yes, yes. Maybe just to add one eraser, maybe the system, within the system, how it protects against unauthorized access or
Yeah,
data breach.
yeah. Like it needs to be authenticated. Great. Anyone who wants to try one more? And then I can show you what I have. Like in terms of availability, do you think the system could afford to be down maybe in the nighttime, or it needs to be available 24/7? Aida, I see your hands up.
Yeah, I think it needs to be available 24/7.
Yeah. So you can say availability is 99.9% or something like that. Okay. Good. Thank you again for your participation, the brave ones. So these are some of like the non-functional requirements, right? So like I just said, it needs to be available. So let's say 99.9%. You could go until 99.999%. I think that's the highest that I've seen. but this is already good enough. So low latency is also a metric you can use. So if a user is requesting, they need to be matched within a minute or less than a minute. So low latency could be your metrics. You can say 10 million daily active users. So then this tells you how much your throughput is going to be. And then you could also, so availability is important, but in match, like when you are matching a rider with a driver, you care more about consistency than availability. The reason I say this is if you are not consistent, some servers might think, oh, this driver is still available, let me book. So then you would have double booking. So instead of double booking, you need to make sure your system is consistent. And if consistency cannot be achieved, just say at the moment you cannot book. You cannot book a driver. And you also know it's going to be read intensive. That means most of the time you're going to have like a get API done right. Okay, so let's, or maybe before I show you, can you think of like major components you would break out to kind of design this right application? I can give you an example. It could be like I can have one box that says payment that could handle the payment service. So the payment process. I don't need to know exactly what the payment process looks like, but I just will have a box to represent that. Can you think of any other boxes? Gabriela, you wanna?
Perhaps we could designate a section for handling requests, like from the right customer to like the driver.
Yep. So let's call that right, for example,
Sure.
the box. Okay.
And
So
another one could
yeah,
be for drivers to like enable their ride services on, because you know how they turn it on whenever they want to start Ubering and then they turn it off. They have their own downtimes as well.
you mean on the
Our
client
services,
side, the user's options to be on and off.
no, on the driver's side actually.
Yeah, on the driver's side.
Yeah.
Yeah. That would be a client feature. That's true. Thank you. Aida, I see your hands up.
Yeah, so Gabi said a section for ordering an Uber, and I think we should also have a section for canceling the order.
Oh, okay. So I want to ask you, can the same service handle these things?
Kind of.
Yeah. Ruth, you also have your hands up.
I think there could be a section for authentication.
Yes, exactly. So we can have a box called odd, and that could be one section. Yes, Matot. I'm sorry if I'm mispronouncing your name.
That's correct. For calculating the shortest route, the shortest path.
Yes, that is true. So we need to be able to calculate the shortest path, and maybe let's call that location service, right? Okay, so we already have quite a lot. Thank you everyone for participating. So these are, and we might have more. So for example, I did include the authentication service. I did include the payment service, but these are like correct answers that would go in. I just wanted to simplify it. So now we have these boxes. We don't know what these boxes are going to do yet, but we we know they're basically catering to a requirement that we have. So the location service, like Matot said, we need to be able to calculate the nearby distance. For that, we need some sort of way to save location and then calculate this nearby driver. So we designated that part to the location service, and the location service doesn't need to know the riders, it doesn't need to know what a ride is when it's requested. So we basically made it simpler by designating just this part to the location service. Then the ride service, I believe, Ida, you said the ride service. So this is the one which the users or the client is going to be calling to handle ride requests, right? So it would have different APIs for requesting a ride, for canceling rides, accepting, declining, and so on. And then we have the matching service that we didn't discuss about. The matching service is basically, so when a ride request comes in, the ride service can call the matching service to get available drivers back. So we are just separating the concerns. So this becomes scalable and it becomes maintainable. So I added a few checks on top. Okay, but we don't have any data flow yet, right? So we need to add that in the high-level design still. So we know we have a few things that I didn't mention are, it also helps you if you kind of sketch out your entities. Like here, I know I have an entity called ride, because depending on how these entities are, it also helps me, oh, there's a lot of relationship here, so maybe I need a relational database, or it's really okay, I can just put them as JSON, and so no SQL database works fine. So it helps you. Here I have the rider has an ID, and I mean a ride, it has an ID because it needs to be identifiable. And then a ride, of course, has a driver and a rider, right? Those are the two matched entities. And so we have the driver ID and the rider ID here. And then there is a status that basically tell us, okay, is the ride completed? Is the ride in progress or requested? There are different things like fare, source, destination, and so on. So here I didn't include the fare estimation, but that could also be one box. So for the actual data flow, I'll try to be a little bit faster now because I think we don't have so much time. Rider requests a ride, and then that goes to the rider service. Then the rider service goes and talk to the matching service, get me a ride. Maybe instead of get me a ride, it could be get me drivers. And then the matching service basically goes to the location service, and in the ride request you have the location of the rider, so you pass that location and say, for this location find me a nearby drivers that are available. So for the available, you will look into driver status. And one thing is this location needs to be updated, right? It's a very frequent read and write. So for that, you could already say, okay, my like a SQL database, that would be really hard to do because I also need to calculate nearby. So I need some sort of geospatial indexing. So here I use some very fast read write database. So in-memory database could be one thing you could use here. And Redis, for example, supports geohashing. So that means if you give it a location, say give me nearby in like it was in 10 kilometers, it would be very easy to do instead of calculating that yourself. And then basically that would give you the nearby drivers. And then now you have a list of drivers that potentially could accept or decline. Sorry. And of course, the driver always needs to update their location so you always know. And here you can optimize, right? If the driver, so from the client side is off and not available, then you don't need to update location and so on. So here for performance, the database choices. For security, make sure this database are encrypted and it needs to be available. So you have more than one services. So you have horizontal scaling. And then to put it all together, you have the right service. When you request a ride, and there's a lot of requests that is coming, it's very good to have an async process here to be able to scale. So what you would do is you have so many requests. Like if you go to Kabele or what do we call it? Like a government office or maybe even Subway, right? You try to order something. What they do is they accept your order and they give you a number. Because then you're not waiting until you get the order, but you have a number and then you're just waiting until your number gets called. So in a similar way, that's a queue, right? You get, when you request a ride, you get some sort of, okay, your request is being processed. And so now it's an async process and instead of waiting until the whole thing finishes. So when you have this kind of scenario in which you have so many requests and your server is going to be overwhelmed, add a queue in between to kind of make this system as this request asynchronous. And like we said, this matching service then has this location service. Basically, you will get nearby drivers, and then the matching service would basically get back to the right service with available riders. And one thing is here I added a notification service because you can push. Are you available to many drivers, right? So whoever accepts, then that would be where your driver going to be. Also here I added like an API gateway. This would be your load balancer. You can also add firewall here. You can have rate limiting in case your API is being DDoSed or really being requested more than what you expect. You can have a cache here. So this layer adds some security. This one adds availability, consistency, and performance. And your database choices are also making sure that it's performant as well as secure. So I am trying to be as fast. This is the last slide. So there are some useful tools. Excalibur I used to design this. I used Excalibur. It's very nice. If you want to try to design something, Draw.io, Plant.uml are really good. This for more like gathering the requirements section. Sorry, someone is not muted. Okay. So these are some of the online tools that I think would be really useful. I also added some online courses that you can check. and some books. So I will share the slide with you, or the organizers will share the slide with you, and then you can have a look as well. So I will open it for questions. Sorry, I'm a bit, I think I took a bit more time.
Not at all. It was great. Thank you so much. Thank you so much, Lydia, for an incredible session. It was really insightful, really.
Thank you.
So if anyone has question, we are going to open the floor for a Q&A.
Yeah.
So if you have any question, you could raise your hand and unmute yourself and yeah, ask away.
And if you don't want to ask the question now, but you'd rather ask me later, I will also have my LinkedIn shared. So you feel free to also send me questions on my LinkedIn.
So we will share the slides with you. We will let me put a link for an attendance form here, and you could fill out that form so we could get you your contacts. Then we will share it through email. So wait, let me send you the link for the form. Um, Sorry. Until then, if anyone has any questions, you can ask. So I've put the form link in the chat, so you could fill out the form, you guys. Then we will share the slide with you through email.
I see one hand raised, Matot.
Hello everyone, hello Lydia. Your presentation was amazing. Thank you for sharing it with us. So my question is system architecture and design the same? And also who is the one like responsible for doing the system design, the high level and low level?
What is the last question?
The responsible one, like who is in charge of doing the system design or system architecture?
Okay, so it might differ based on the company, right? But I can give you two perspectives that I have from IBM and also from AWS. So in IBM, we used to have a dedicated system architect. Those have a very specific skill that is for, so architect and system design, I use it interchangeably, right? So in
Hi, Leilu Baye said, can you mention some books to help us in system design?
yeah, I've linked it here. So designing data intensive application and clean architecture. When we share this slide, then you could have these information as well.
Yeah. So yeah, and Daniel, he said, what's your Amazon experience? How we want to get to the level from Ethiopia, and like for one university tech student, give us an advice. He's a fourth year software engineering student, I guess.
Okay. So for me, when I finished high school, I applied to a lot of universities, and then I got one university in Germany, right? So one of the first things that would help you is always like applying to universities that are outside. And for being accepted, what helped me is one, having extracurricular activities. So maybe you are the president of the IT club, or the president of, or the speaker of, like having another activity other than this, the actual studying part helps. Your grades help. But if you don't want to go with with the university route, uh, what you could do is have try stuff, right? If you have, for example, your fourth year, then you could already apply for internship. Applying for internship inside and out. I don't know the how easy it is to get a visa, but even in Ethiopia, just build your career, try projects at home. It's easy to build stuff nowadays. There are a lot of open source and add it to your GitHub. So creating a GitHub account, adding a few projects there, have a LinkedIn profile, make sure you have a CV, and there are different CV tools that helps you create a CV. So, and then just slowly add your experiences, right? Your fourth year, maybe an internship, then a job, and so on. So these things will help you, I hope. And if you have like a specific question, maybe you can also reach out to me on LinkedIn.
I think that is it. Anyone else that has a question? That have
Yeah, I think that's it. Any question about system design?
okay, Daniel raised his hand, I guess.
I'm not sure how I can give advice about freelancing job since I don't have experience in freelancing job. But um, if it is about how to be a good software developer, sorry, someone needs to be muted.
I think your mic is on.
Oh, I'm really sorry. I didn't notice.
Um, so I was just saying I don't know how it is for the freelancing job because I've never done it. But if it is about I'm fresh in software developer, how can I build my career? Is basically what I said earlier. Really, it starts by applying to a lot of places. So, for example, when I was applying for internship or even job, I was applying to a lot of places, even some places which I thought I was not qualified to, right? So don't cut yourself short, mm, and always do more at home. I think in the tech job, the like how how much experience you have really matters than the like the depth of the maybe the academic growth. So having a GitHub account really helps. Then try if there. I don't know how else to help because I really have not done freelancing jobs. So I'm sorry, I don't have experience on that one.
Um, I
There
think
is one which I can answer. Can you tell me your learning experience before AWS? So before AWS, to start, I did my high school in Ethiopia, and then after Ethiopia, I applied to a university called the Yakabs University. It's now called Constructor University. They also used to give a good financial aid, which I can imagine is something that was important to me. Um, and so I went there. It was a 3-year computer science course. So I have after I finished my bachelor's, then I joined IBM and then AWS. Uh, okay.
I think we should wrap it up, right? Um, So everyone, to get the slides, we will share it to you through your email via email. So please fill out the form. We have put it in the chat here. So you could fill out the form, and we'll share the slides to you via email. And uh, also, you could you could share you could. You could share about WTM Ethiopia. So we are an initiative here in Ethiopia that works toward just encouraging women in the technology field. So to share the word. And yeah, I think thank you all for joining. Thank you, Lydia, for the incredible session. It was incredible. It was so insightful. So thank you very much.
And thank you for having me as well. I'm really happy to be part of the community and keep up the good work.
Uh, Thank you. Thank you. So, Ida, if you have anything else to say, the floor is yours.
Hello everyone, am I audible?
Yes. Yeah. We can.
Thank you everyone, I'm really glad to be here. So first thing, I am Ida. I'm proudly a WTM core team member. I volunteer as event and social media lead. So thank you everyone for joining us. It was a great session. Thank you, Lido. Thank you so much, everyone. So yeah, see you next time. We will be having a next session too. We will be having a session for the couple weeks. So yeah, thank you so much, everyone.
Yeah. I think, Lydia, I think you could leave now.
Uh,
So let's not take much of your time.
Thank you very much. Bye.
Thank you. Thank you.
Thank you,
So
Lydia.
everyone, fill out the form. We will share the slides through email, and after that, we might have some events planned, maybe like a hackathon or something. So it would really help us to have your contact